Hey everybody, this is Larry. This is January 4th. Is me doing a bonus question. And yes, I forgot to did this in the other video, but hopefully, if you're doing it with me here, you'll see that, there's an unbox surprise. If you click on it, you get 10 lead coins and a little closer to a free month of Leetcode or whatever it is. All right, so yeah, so today I am going to do a bonus, if you will, an extra problem, just to kind of get my practice on a little bit, because the other one, I guess I've done it a few times or whatever. How do I, okay, to do. So let's do another one. Let's go, RNG, create maximum number. Okay, this looks like an interesting one. And again, not a premium question. I feel like whenever, those of you who've seen me did it a long time ago, I keep on doing RNG and then I keep on getting premium ones. But now that I'm, now that I actually have premium, the RNG is giving me non-premium ones. Anyway, okay. So today's problem is 321, create maximum number. So you're given two integer arrays, nums1, nums2, m and n, okay, whatever. But they are different lengths and the digits of two numbers. You're given an integer k. Create a maximum number of length formed from digits of the two numbers. The relative order of the digits from the same array must be preserved. Return an array of the k digits represent a number. Okay, what does that mean? Number of the length k from, what does that mean? Give me an example. This is like, I mean, these examples are okay, but I see. This is a way, I mean, this is not, I don't think this is an outrageously hard problem. I just think this is a really poorly worded problem, because you can't just be like, oh, here's some digits, make a number. You have to explain the rules on how to make the number, like I don't know, just I don't know, this is kind of a little bit whatever, but okay. So how would I do it, right? So k is less than 1,000. I mean, my first idea that I'm thinking in my mind is dynamic programming, right? Does it make sense? Also, I feel like my neighbor is vacuum cleaning. So if you could, I don't know if you could hear it, but if you can, my apologies. Hopefully, I don't know. It just doesn't. Hopefully, it doesn't matter. This is a hard one, though. Actually, I think initially I thought you could. I mean, and n squared is going to be fast enough. I do suspect it is going to be some sort of dynamic programming, but I think there's even a more, let's say 500, right? So 500 times 500 is what? Quarter of a mil, right? And a quarter of a mil times 10 is 2.5 mil. That's going to be cutting it close. So there's a dynamic programming where, no, maybe not. Well, they're not 2.5 million state. It's just that it'll be. All right, I guess let's try that, and then we'll see. No, because then each state will be 10 times some binary search. So my idea was initially that, basically you ask yourself, okay, can the next digit be a 9, right? And then just greedy, if it, you do a binary search on the left to get the first 9, or you get the binary search on the right to get the first 9 on the right, or nums 1 and nums 2, and then you recurse based on that, and then now you're one fewer digit, and then on the next digit you ask, can I get a 9, can I get an 8, etc., right? And in this particular problem, you always want the earlier number because that just gives you more option, right, in a greedy way. Is that the way to do it? I think the tricky thing is that the bounds are kind of tight on Python. I think one thing that I'm kind of bad at is that, or just PTSD, if you will, is that Python, Leetcode Python performance has been kind of bad. So, or at least like not parity, So, yeah. I'm trying to think a little bit. I mean, that definitely is a but then you have to. I think the other thing is this path construction as well. So that's actually a little bit tricky. My other thought is try to think whether it can be greedy. And it's the same idea, but instead of doing that recursion that we talked about and then just kind of hope that it works out. This is a hard problem, actually. I was wrong about. Well, I mean, I feel like if I was in C++ and maybe I will have to switch, I feel like I wouldn't necessarily worry about it. There's 250,000 states. Each of those states you do 10 binary search on up to 500 elements, which is less than 10, so 100, so like 25 million operations or something like this. And binary search is pretty fast, but it's just a very quick check. It's just that in Python, at least on Leetcode Python, it's not parity, where in C++, I feel like that's maybe even okay. The question is, like for example, for this one, right? If we say, okay, let's say we try 7, but then we know that we can't be 7 because we don't have enough digits to fill it out. So then now we try 6. How do we know which 6 to tick? This one or this one? Or does it matter? Maybe it doesn't matter. Well, in this case, it doesn't matter because there's nothing in between. But can it matter? Let's say we have 6, 7. I don't know, like 2. Does that matter still? Well, by definition, if this number is bigger, then you would have taken that instead. And if it's smaller, you don't want it anyway, because no, you could take the wrong one, because for example, even here, if you take this 6 instead, then you have 6, 6, 7, and you can't get the other 7. But if you do it the other way, you have to take this 6 to get this 7. Can I skip the binary search? I guess I could skip the binary search if I have a lookup table. This is so silly. I feel like I'm doing a lot. So okay, I think I got it maybe. but this is not, I don't know. We'll see how this goes, to be honest. But the lookup table is only 500 times 10, so it's not that big of a deal. But that's, okay. Let me play around with it. I know that I'm not very good on the explanation right now because, to be honest, this is a new problem to me. And like I said, I'm not quite sure I'm even right on this one. But I am going. I'll explain my logic and my thought process. But I'm not sure that this is right. But basically, I'm just creating a over one index for lookup for an array so that we know what the previous number is, or the next number, but I'm doing it backwards to get the previous number. Okay, yeah. So basically, what we want is let's say lookup is equal to okay, let's say n is equal to length of array. Then we'll do n is n times length of n, right? And then this we want 10 of them, right? Okay. And then basically for the digit, I didn't know zeros, or oh, they are zeros, they just didn't put any. Okay. For x in range from 0 to 9 inclusive, for index in range of n minus 1, we're going backwards. Let's see, so last is equal to n, and then basically look up of x of index is equal to last if array of index is equal to x, last is equal to index. Okay. Let's just say return and then let's do create lookup of nums1. Let's just say lookup 1, and then lookup 2 is equal to create lookup of nums2, and then we print them really quickly just to kind of see if I'm in the right place. It should be times n, that's why okay, so 0, 1, 2, so what am I doing? 3, 4, so okay, this is kind of a terrible input. Need something with more duplicate. Okay, fine, I guess I'll have to put in a duplicate. So basically, for example, let's just say 1, 1, 1, 1, 1, 5, 5, 1, 1, 5, 5, something like that. Okay. Okay, so then now 1 will look to the next pointer, and then okay. Good. All right, so we have these lookup tables. Now I think we can do dynamic programming. Basically, the recurrence that we want. Wait, is wait. I forget that you have to do output sensitive. Let me think for a second. What's the best way to do it? Am I really doing this complicatedly? Like I think part of me is just like I'm in disbelief that like this problem could be that hard to do, and I could do it, but it's just I'm wondering if I'm missing something more obvious. I guess is why I'm kind of a little bit curious to accept and raise it slow. 6. I think this case is the one that I don't know how to do in a good way. Guess we can also skip. What do we return? Sorry, I'm just thinking right now. Like I said, I don't know how. This one's kind of hard. Like we could do it with DP, but I just feel like that's really hard. Okay. I mean, it is what it is. Okay. I mean, yeah. Let me see what I can do first. Okay. So let's just say, possible. Let's call I1, I2 for the indexes. How am I structuring this? And I don't know how to do the tiebreaker. Like if this can be a 6, then what? I mean, even if you maximize the next digit, you have to maximize the digit after that, right? I don't know. Wow, maybe I'm doing it really the wrong way. I mean, usually these kind of problems are very greedy in that you just test to see if a 6 is possible, and 6 is possible. Is 7 possible with 3 digits afterwards? But then now you have a branch, and I think that's the part that I don't understand. How you can, because you have a 6 and then you have to take it in both places. And then in one case, you can have a 7 possible, but then in the other you don't, right? Which is kind of a weird thing, maybe. Maybe not. Maybe I just have. This is kind of okay. Maybe the way that I do it isn't traditional top down, but just a weird sort of bottoms up. We'll see. Okay, let's try it. Okay. So let's say answer is equal to and we always have to be true because, well, like there's always an answer is what I mean. Not that. Okay, so basically for, in K, we ask ourselves, can this number be possible, right? And then we look at that from the other possible set. So let's just say, I don't know if this is quite right. It is very weird. So basically, yeah, for x, y in possible, or I1, I2, maybe that's a little bit better, right? Then we want to say, it is possible if we take a 9 here, okay, so just say found is equal to false. So then here, if it's possible, we always take it no matter what, right? But basically, okay, take the 1 from I1. So, okay, so then now, lookup of digit of I1. So this is going to be the next index, right? So and I1 is equal to this. So then now, also need n1 is equal to length of nums1, n2 is equal to length of nums2. So then basically, so I need whatever, something like that. Yeah, okay, fine. Basically now that we have a new index, so n1 minus n1 and I1 is going to be the number of digits left. I need to also do an additional thing of just n, maybe. Yeah. So okay, nums1 left is equal to this thing. Nums2 left is equal to n2 minus I2 because we haven't changed it. So then now if nums1 left plus nums2 left is greater than or equal to the number, so these are the number of digits left, and then k minus used is maybe we want to set is it k minus used? Yeah, that's number of digits that we still have to fill minus 1 because used is 0. So then, and we assume that using this we used one of the digits. Then this is a good one. So then maybe we have a next possible. So then ni1, I2. Okay, and then ni2 is equal to lookup of digit of I2, and then we do the same thing really. I probably could parameterize this, but okay. And I guess we don't need a found. It's just basically, oh wait, I mean, I guess we do. So basically, now after we go forward, if next possible is greater than 0, then that means that we're good, and then we can break. But we also want to answer that append digit, and then yeah, and then now possible is equal to next possible, and I think that's the idea. I don't know if it's quite right though, to be honest. Oh yeah, whoops, n-1. I'll look up 1. Yeah, you're right. Well, do I not progress? 4-0, and then, yeah, this doesn't move for some reason. Okay, so that means that we 9. This one doesn't. Oh, it just assumes that this one has it and then just keeps going to the end. So we need this to. I don't know why I didn't think about this, or at least I didn't. Is you go to n, or not you go to n, less than n. Then we do this thing. That's what I meant to do, but I think I just forgot about it, and I was worried about getting an error and not correctness. Yes. Again, thank you. You are so smart. Okay. We missed the first digit, but maybe... nope, we missed a lot of digits, really. Okay. Let's actually add an assert here. Okay, so that's good in that, you know, tell me it's wrong. Do I have any typo here? Why is this so weird? Because it feels okay. But then for here, it does not find a 9. Oh, it asserts after the last one because it finds an 8 for the first one, but not the 9. Why not? Tell me why. Unless I missed the 9 somewhere. Why doesn't it? And 2, do I do this right? It doesn't go there. He doesn't even go there. I expected 9 6. Oh, because it doesn't count the first digit because I messed up. Because we technically start from before the first digit. Okay, that's an easy fix actually. Well, relatively. Well, we start at -1, I guess is how we do it. I don't know if that quite works with the formula though, with the n1 minus. This. Let me think about this for a second. So basically, we want to put the next number. So okay, fine. I think I do this, and then we do this +1 to consume it, maybe. And this is where you have to define this very precisely. Okay, so we're a little bit better, but we're still getting an assertion error. But 9, 8, 6, 5, 3, and then we just keep going somehow. What? Now, this one is actually normal to hit, but why do we get so many numbers? Oh, it's right. Huh. Why was it printing so much earlier? Okay, well now it's still wrong for this one, but that's okay maybe. Seems like I have another off by 1. Let's see. 9, 9, yep. Yeah, I feel like I have an off by 1 because now we move it to the next one on top. Okay, I feel like we're close though. It's just that, well, we're not right, but 9, so if things is 0, 0, that's actually tricks it for it. 0, 2, so this is at the end and this is at the end, right? And then because both of these cases, is that true? I think this is wrong. There actually should be a third force here. That should be impossible to hit on the right one. I don't know why this is. Am I just misreading this? I think maybe I'm just confused because I think this is not for this particular. I read this as the one for the first input, but actually I think this is for like the second or third input. That's why the new UI kind of messed that up a little bit. But I think I just misinterpreted the UI because now it's just missing, right? Okay. The other one I think is more reasonable. So this 0, 2. So that means that going from 0, 2, yeah, I guess so. And here it could be 939, this could be 989. So I guess they're both true. Okay, so 0, 0, and then it gets a 9 as a possibility. Maybe I should do digit and then next possible. Maybe that's a little bit better for debugging for consistency. I know that it goes to the next one, but I think just for, okay, right? And then now it thinks 2, 2 is good, but that's not true, is it? I think this is this plus 1. I think that's why. Another off by 1. Oh, still wrong. Why does it think 2, 2 is a valid thing to do? Oh, this is this minus this plus 1. Whoops. Not a parens. Maybe that's why. Okay. This is a very hard problem, to be honest. Let's just take it out because they're going to give me a wrong answer. And I can't even debug it. Alright, I am going to take out this other print statement. But then after that, I think I'm just going to submit. Beat 100%. Am I missing something really obvious? I feel like the way that I did it is kind of really hard. So what is the complexity here, right? Well, this next possible set can only contain n by m, and it may not seem possible, but because this set is all the indexes of n by m, right? So that means that next possible is going to be at most half at most n1 times n2 elements each. Well, I mean, and a lot of those it's not possible. It's just that in theory, right? And this is obviously O of k, and this is O of 10, or number of digits, if you will, D for digits. And then, as I said, this is going to be n1 times n2 at most. So that means that the total complexity is going to be O of k times D times n1 times n2 time, which for this one, that seems a little bit slow actually. Because this could be 1,000. 1,000 times 500 times 500 is actually pretty slow. I mean, a lot of these states are not possible, but that is scary to think about. And you have to, I think you have to do some amortization math. I guess in the worst case, if everything gets hit once, Well, it's not possible to do n1 times n2 because I don't know. I don't know how to analyze this, to be honest. I think I'm just. I mean, this is a pessimistic bound. I think there's some optimization math on it. I'm just thinking about edge cases in which this case is harder than you know. So I'm just trying to figure it out a little bit. Um, but yeah, it is just greedy. Can I figure out a better bound? Well, if they're all the same number, then in the case where they're all the same number, then this is just it's not n1 times n2 because that's not possible. Because if they're all the same number, then you almost have a it's going to be just one of them doesn't one of the n if they're all the same number, then you could think about it as n1 plus n2 is equal to k used, right? So then in that way, it's just going to be k times n1, and that's why that's going to be fast times 10, I guess, for the d. If they're all different numbers, then you jump ahead so much that a lot of the things are not possible. So I don't know which one is the worst case, but I think that's why this is the upper bound. I think it's closer to n1 times n2 is the bound. Yeah, and same thing for space, because space is just bounded by this anyway. So yeah, this is a very hard problem. I don't know that I explain it right. Okay, but yeah, do let me know what you think. Yeah. Yeah, let me know what you think about this problem. Let me know if you attempt it. This is not a premium question, so you could do it with me. But I don't know. I clearly struggled a bit with this one, so definitely let me know. Yeah, that's all I have for today. Let me know what you think. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.